Hello and welcome to today's lesson where we're going to look at heating and cooling curves, which forms part of the particle model of matter topic in GCSE Combined Science Physics. So if we're successful and we learn in today's lesson, we should be able to observe the change in the internal energy of a substance. So we should be able to define what internal energy is, draw and label what a cooling curve shows with changes in energy store, and then observe how the internal energy of a system can be changed, which falls into the following part of the AQA Combined Science Specification for physics. So we're looking at internal energy, temperature changes in a system in specific heat capacity, and changes of state in specific latent heat. Now the internal energy of a substance will increase when it's heated. Heating an object puts energy into that object. So we say work is done into the object. So heating something up will increase its internal energy store. Now this will cause either the temperature of the object to increase or the object to change state of matter. However, both cannot take place at the same time. Either one or the other will take place. We can demonstrate this idea in a heating curve. So a heating curve shows the change in temperature for a substance when energy is placed into the substance. Now on a heating curve, the temperature of the object is placed on the y-axis and the energy supplied or the time is placed on the x-axis. Now when the temperature increases, the kinetic energy stored changes, and this is shown in an upwards line on the graph. Now when the state changes, the potential energy store of the system changes, but this doesn't affect the kinetic energy store of the internal energy, so therefore it doesn't affect the temperature of the system. So what this means is that when you change state, you are changing the potential energy store, not the kinetic energy store, so you achieve a flat line on your heating curve because the temperature is unchanged. So we say that this energy store change is hidden from the temperature observation, or it is latent. So the energy needed to change state is called the latent heat. Now this basically means the hidden heat, as the energy is hidden from the thermometer. The thermometer cannot detect this change in energy store. Now the specific latent heat is the energy needed to change the state per kilogram of the substance, because specific in physics means per kilogram. Now the latent heat needed to melt a substance is smaller than the latent heat needed to boil a substance. Now you can tell this from the graph, as the line is longer for boiling compared to melting, so more energy would need to be supplied to achieve this. This is because there's a greater change in forces of attraction going from a liquid to a gas compared to a solid to a liquid. Now we can identify the state change from a heating curve. It's a flat line. Now remember, when there's a change of state, there's no change in temperature, because the work is being put into the potential energy store. So when there's a change of temperature, there's no change of state. So you can see on this particular graph where there's a change in potential energy store. Now the change of temperature is where you have a change in the kinetic energy store of the internal energy. So either you get a change of temperature or you get a change of state. Either you're changing the potential energy store or you are changing the kinetic energy store. Now once again, when a solid is heated, work is done to the particles to make them vibrate more, which means their temperature increases. The potential energy store of a solid remains constant, but the kinetic energy store would increase. But at the melting point, the particles do not vibrate any faster, meaning that the kinetic energy and the temperature are constant. The forces of attraction that keep the particles in a rigid shape are broken, and the potential energy store increases. Now at boiling point, the particles do not vibrate any faster, meaning that the kinetic energy store and the temperature are constant. So it's very, very important we note this, but the forces of attraction holding the particles together are all broken. So this takes much more energy than when melting, since all the forces of attraction need to be fully broken between those particles. Now just to note, the physics of heating and cooling is identical. However, heating requires work to be put into the internal energy store of a system to increase it, whilst cooling requires work to be taken out of the internal energy store of the system, decreasing it. Now in this example, the internal energy is decreasing with time as energy is being taken out of a substance. It is a cooling curve. Now on a like I mentioned before, on a temperature curve, when the line is flat, it's the potential energy store that is changing. The temperature is constant as it is changing state. But on a temperature curve, when the line is moving up or down, the kinetic energy store is changing because the temperature is changing. So we can summarize what we've learned in today's lesson. The energy stored inside a system by the particles that make up a system is called the internal energy. Internal energy is the total kinetic energy and potential energy of all the particles that make up the system. Heating changes the energy stored within the system by increasing the internal energy, which can either raise the temperature of a system or produce a change of state. If the temperature of the system is increased, the increase in temperature depends on the mass of the substance, the type of material, and the energy inputted. If a change of state happens, the energy needed for a substance to change state is called latent heat, and when a change of state occurs, the energy supplied changes the energy stored but not the temperature. Now, if we've been successful and we've learnt in today's lesson, we can define what internal energy is. We can draw and label what a cooling curve shows with changes in energy store, and we can observe how the internal energy of a system can be changed. I hope you've enjoyed today's lesson on heating and cooling curves, which forms part of the topic of the particle model of matter in GCSE Combined Science. Thank you very much and have a lovely day.